Yeah.
Which bears? What are they?
Grizzly bears.
Big bears.
It's the bear and sea bears.
I love that show.
I know, right?
Alright, so like we talked about, all things in the universe can be split into two categories. Either either energy or matter. Okay, we talked about matter a little bit. Matter is anything that has what?
Matter.
Mass and volume.
Space.
If it has mass and volume, then it's matter.
Is that where we put the 1 and 2? That's what
Yeah.
Yeah. I like your version.
So, if it has mass, has volume, then it's matter. So all the physical material around us, that's matter. But there's also energy. Right? And energy is all the other stuff. Heat energy, light energy, sound energy. Okay? These are other, this is the other category of things. So when we talk about energy, there's two broad categories. There's kinetic energy, which is moving energy. The energy of moving that can be used to do work. Like water in a stream has energy of motion. It's moving, that movement is kinetic energy. Whereas other type of energy is potential energy. This is stored energy. A battery, for example, has stored energy. Water behind a dam has potential energy because it has the ability, when it does move, to do some work. But when it's stored up behind the dam, that's potential energy.
Mr. Dudas, watch your language. What do you say?
Bad word. Damn.
And as you guys know, we have some rules. What is the law of conservation of energy and matter state? 3 things. Give me one of them, Laura. Energy and matter what? Cannot be created?
Object in motion stays in motion?
No, you're talking about Newton's laws.
I know.
Yep.
Matter cannot be destroyed.
No, but it can only be
Transfer.
yes. So energy cannot be created, cannot be destroyed, and only change forms. This is true of both matter and energy.
What?
So you can take light energy, using a photovoltaic cell, transform that into electrical energy. And you can take electrical energy, transform that into heat energy.
Like
But you're not
solar power
creating, but you're not creating or destroying energy. You're just transforming it from one form to another. Donovan?
So like, where do we get all of energy?
The energy in the universe is constant, and it's energy on Earth generally comes from the sun. You know, came from the sun at some point in the
Yeah,
past.
where did it all come from at the beginning?
I don't know.
Dinosaurs.
So we have moving energy, which is kinetic energy. You guys don't have this, right? Okay, when you draw back the string of a bow, again, you're giving up potential energy. When is it transformed into moving energy?
When you let go.
Yes, when you release it. Okay, if you hoist up something up high, it has potential energy, and once you drop it, that's transformed into kinetic energy. All right, well, we're going to be talking, this unit focuses on heat. Heat is a type of energy. And what causes, so Abby has some water there. That water is probably cool-ish. Okay, what's the difference between that and the equal bottle of warm water? What's different about them?
The
What's happening? What's
different in
happening
space.
for the temperature, Abby?
The molecules are moving faster in one water.
Yeah, it has to do with the movement of the molecules and the speed. Okay? Heat is created by the vibration of molecules. And the faster molecules vibrate, the greater heat. Okay, so if you look at a horseshoe being heated here in the fire, this blacksmith, I guess. As it's heated, those molecules that make up the iron in that horseshoe, they move faster as they're being heated up. Okay, that's increase in the heat. As it cools down, those molecules, they vibrate more slowly. There's less heat available.
He's playing horseshoe.
Now, you probably know this, but as you heat up matter, what generally happens to it? Almost always. To its volume. What happens to the volume of something as it's heated? Laura?
Like, they vibrate faster.
It does, but what about its volume? What? Yeah, it expands. Materials generally, when heated, will expand, okay, and spread out. Okay? The temperature increases.
That's mixed up.
Yeah, the molecules, so you're going to have to write all this in. So, where are we?
It's
Oh, you're
we
right.
vibrate, but we have more.
Yeah, so just fill it in so it makes sense. So temperature increases, molecules vibrate faster, and they spread apart. Almost all matter will expand when heated, and what's the opposite of expand?
Shrink.
Contract when cooled.
How are molecules?
That's called thermal expansion. Thermal meaning heat, expand meaning get larger. And this is how a thermometer works. Thermometer is obviously a tool used to measure temperature. And a thermometer is basically just a very thin glass tube usually with a liquid inside. Liquid might be mercury. Not so much anymore. The thermometers we use are not filled with mercury because mercury in the environment is not is toxic. So we don't use them because sometimes thermometers break. Our thermometers are generally alcohol thermometers. But anyway, there's a quantity of liquid in a narrow tube, and as it gets warmer, what happens to the liquid?
It raises.
Well, it expands, and the only place it can go is up the tube.
Well, that's
And so it's marked to a scale that you can judge the temperature from how high up the tube it is. So as it gets warmer, it expands. As it gets cooler, it contracts and comes down the tube. And that's how thermometers work.
That's cool.
Now, this is something that's important. You know, I noticed this a couple weeks ago over fire break. We went to New York. We were going over the George Washington Bridge. And as we were driving, we saw these exact same metal pieces in the road. Going over the George Washington Bridge, okay, over the Hudson River, I see these things. Now, what is the purpose of those? If you look at them, there's a few of them as you go over the bridge. You know why they're there?
Aren't they with the draining water in the streets?
No, not for draining water.
For holding it.
No. Has to do with what we're talking about, thermal expansion.
So there's more room for
Donovan?
Because when it gets warm, they want it to have space to go without like damaging the bridge over
Yeah.
time.
Exactly. When I was going over the bridge, it was cold out. It was in the winter. Okay, so what happens to the pavement and the steel of the bridge and everything when it's cold?
Shrinks.
It shrinks. Okay, and so these rods, these plates, give it room to shrink without becoming disconnected. What happens in the summer when everything heats up? It expands, and this gives it room to sort of come together, okay, so that the road doesn't buckle. These are called expansion joints. And you'll see them in sidewalks as well. If you walk along a concrete sidewalk, you'll notice there's like sections, it's just full concrete, but then every once in a while there's a layer of almost like a foam material between two sections in the sidewalk. That's the same thing, it's an expansion joint. It's meant so that in the summer, when the sidewalks swell, okay, they can compress that foam rather than just break it. When you put in, I put in a floor in my living room, like a hardwood floor, and you have to leave a gap all around the outside. Okay? And again, that's because when the wood expands, okay, there's some space for it to go instead of buckling. The doors in your house, they may start to get sticky and not open as well when it's really hot in the summer. You know, you may have to jam them shut. That's because the wood expands as it gets warmer. So these are all examples of thermal expansion. If you have a jar and you can't get the lid off, okay, because it's really tight, you may have heard run it under hot water. And again, what that does causes the metal in the cover to expand a little bit, loosening it up.
Oh.
These are some train tracks that were damaged because of thermal expansion. Here is another example. These workers, these are some train tracks, obviously. And what they do sometimes, in extreme cold, sometimes the rails will separate because they've contracted so much. And what they'll do is they'll put a rope along the tracks, soaked in oil, light it on fire, and cause those tracks to be heated up to start to expand and reconnect so that they can be fixed.
How do they put it out?
What's that?
How do they put
It
the
just
fire?
burns out. It's just the snow. Okay, so the fuel will burn off and eventually that fire will go away. All right, let's finish this slide, I guess. So you're going to have to memorize some temperatures. You probably know several of them. Okay? Now, there are 3 temperature scales we need to be familiar with. Celsius, Fahrenheit. Another one you may not be familiar with is Kelvin. All right. So, your body temperature. You probably know it in Fahrenheit. What is it? 98.6 is average human body temperature. Does anyone know what it is in Celsius?
32.
37.
37. You need to memorize both numbers.
What is it in Kelvin?
310.
Yeah, if you follow across, you can use these charts. So we have 98, yep, 310. So yes, your normal body temperature is 310 degrees Kelvin. How about room temperature? Obviously, the temperature of a room could vary. But when we say room temperature, we mean, I don't know, about 68 or so.
Ooh, 62.
That's 20 degrees Celsius. How about the freezing point of water in Fahrenheit? Yeah?
32 degrees.
32 degrees Fahrenheit. How about Celsius? 0. And the boiling point of water in Fahrenheit? 212 degrees Fahrenheit or
100.
100 degrees Celsius.